All right, for the polynomial division homework, the first thing it wants us to do for number 1, it wants us to evaluate the function kind of the long way by plugging in the 2. So f of 2 will be equal to, I'm going to kind of leave a spot so you can see all of my plugins. So I'm plugging in a 2. And so remember order of operations, we want to deal with the exponent first. So 2 to the 4th power is 2 times 2 times 2 times 2. So we're going to get a 16. 2 to the 3rd is 8. 2 to the 2nd is 4. And then we have just our 2. So now I'm going to multiply all of those that I just got from the exponents. And this will equal 32 plus 40 minus 20. Minus 40 minus 12, which if we put that all together, that will be a 0. Now, if we do synthetic division, what we've seen is that that should give us a 0 in our remainder. So I'm going to put the coefficients, they're in descending order, 2, 5, negative 20, and negative 12. Bring that down, we get 2, 4, 9, 18. 13, that makes 26, positive 6, positive 12, which has to give us 0. All right, now it wants us to do f of negative 3 the same way. So f of negative 3, we're going to get 2 times that negative 3 to the 4th plus 5 times that negative 3 to the 3rd minus 5 times that negative 3 squared minus 20 times that negative 3 minus 12. So if we just stick a 3 in, or minus 3 in there, minus 3, minus 3, minus 3, this is going to be equal to 30 when we simplify that. So again, doing your exponents first and then multiplying them. And so then when we do our synthetic division, let's see what happens. Again, let's put the coefficients. We have 2, 5, negative 20, negative 12. Drop that down, multiply, that's negative 6, we get negative 1. That will be a 3. We have negative 2, 6. And that will be negative 14. Negative 14 times 3 makes a positive 42, which leaves us with 30 left over. So if it's done correctly, we should be noticing that the function values, or the outputs, and the remainders in synthetic division are the same. And for me, synthetic division is easier. Don't have to worry about exponents. And this is really, that's that remainder theorem that we talked about within our notes. All right, so now next question. What does it mean to be a 0 of a polynomial? Well, it's an x value that gets us 0. So if we know that 1/4 is a 0, we could write x minus 1/4. But sometimes a little easier would be 4x minus 1. Again, thinking about where that 0 comes from when you solve the equation. When you set it equal to 0, how you add 1, divide by 4. That's one thing to keep in mind when we're working with our fractions. So it says use the remainder theorem to find the remaining quadratic factor. So if we know that's going to be a 0, then what we saw is that we can use that to see what is actually dividing up that polynomial. So I'm going to write the coefficients. We have 20, 39, negative 3, negative 2. That's coming from those coefficients. So I'm going to drop down the 20. 20 times 1/4, that just means to really divide by 4, which makes 5. 39 plus 5 is 44. Multiply that by 1/4, that makes 11. Negative 3 plus 11 is 8. 8 times that 1/4 would be 2, and it does make us have that 0. So the resulting quadratic is going to be 20. We're now x squared plus 44x plus 8 times, I'm going to use that 4x minus 1, just so that way you don't have to worry about the fractions. Now it says use the resulting quadratic to find the other zero. So that just means I'm going to factor this guy. So the GCF here is 4, and I'm going to have 5x squared plus 11x plus 2, and then I still have that 4x minus 1. Now this guy right here can factor. I'm going to do the A times C method, so really that means 5 times 2 is 10, and then we're breaking up the 11. So what multiplies to 10 but also adds to 11? Well, that's going to be a 10 and a 1, so we're going to write that as 10x plus 1x, and this way we can do our little grouping. So just worrying about that part, I'm going to look at those two. They both have a 5x in common. I'll pull that out. I'll be left with x plus 2. The next part, they don't have anything in common. I'm going to write that as a 1, x plus 2. And so then what we have is, let's see, it'll be 4x minus 1 times the 4 times, out of this stuff right here, our x plus 2 factors out, and then the leftovers is going to be the 5x and the 1. Okay, so this was what that polynomial that we got out of our synthetic division factored to, and then I just wrote my other factor right there as well. Okay, so that's totally factored. We can write the 4 in the front if you think that will look better. And there's a variety of other ways you could have done that. Notice that this 4, if we had fractions in this guy, it wouldn't have been that bad because that 4 would have gotten rid of them. So just something to think about. There's more than one answer for these. And so my zeros are going to be when 4x minus 1 equals 0. We already know that's 1/4. When x plus 2 equals 0, that's going to get a -2. And when 5x plus 1 equals 0, that's going to be -1/5. So those are my zeros. All right, so again, this would be, if it said just give me the factorization or to factor, there's all my factors, and then what I just kept going is setting them equal to 0, and this is when you find the zeros. All right, we're going to skip number 3, not going to work on that long division, that's okay. Going to number 5. So we're still going to kind of be working backwards. We need something that's degree 4, and then it shows us all of our zeros. So if I have a 0 that is 1, that comes from the factor x minus 1. When I have -3/2, that we could write it as x plus 3/2, but even better would be to write 2x plus 3. So keeping in mind that when you set this equal to 0, it turns negative and it divides by that coefficient. So I'm just kind of checking. And then 0 is sitting there, but it has multiplicity 2. Well, that comes from just an x, and we'll square that. So this is our polynomial. It will be degree 4 because we'll have an x to the 1 and we'll have a 2x to the 1. We can multiply that out. We can also just leave it factored. That's fine too. If you want to multiply it out, you should end up getting 2x to the 4th plus x cubed minus 3x squared. But again, either one of these is perfectly fine. All right, for number 5, we want degree 3, and it gives us, well, it looks like only 2 zeros, and then there's another condition. It needs to make sure that if you plug in a 0, you get -36. So for the 0 of 2, I know that's x minus 2. For the 0 of 3i, that's x minus 3i, but remember those always come in pairs, since it's conjugate pair, so I'm going to write x plus 3i also. So we know that we have zeros of 3i and also -3i, that's its conjugate pair. Now, the reason for that 0, -36 is because it's saying that there's going to be some coefficient in the front. Not quite sure what it is. We'll find it in just a minute. So what's nice about the conjugate pair, when you multiply that out, you're going to get x squared plus 3ix minus 3ix minus 9i squared. And so those will cancel each other out. Remember, I squared equals -1, so this will become a plus 9. And we have x squared. So we're looking at f of x equals a times x minus 2 times x squared plus 9. It just looks a little neater that way. And then we could multiply it out or just leave it factored, like similarly up above, but we do need to figure out what this a is. So we know that f of 0 equals negative 36. So when I plug in a 0, this is supposed to equal negative 36. So let's see what happens. This will be a, that's negative 2 times 9 equals negative 36. So a times, that'll be a negative 18 equals negative 36. Divide by negative 18, we get that a is equal to positive 2. And so if I go back, this 2 is what that a should be. So my function, f of x, is really 2 times x minus 2 times x squared plus 9. That's beautiful. That's just factored out. If you wanted to, you could multiply it out. So this is our answer. Or we would write f of x equals, and I'd start by distributing those binomials first. So we'll get 2 times x to the third plus 9x minus 2x squared minus 18. And then when you multiply that 2 in, you'll get 2x to the third plus 18x minus 4x squared minus 36. If you put it in descending order, that'll be 2x to the third minus 4x squared plus 18x minus 36 is another way that we could write that function. Again, that's in descending order. So hope that helps.